So let's see if we can convert from general form to gradient intercept form and back again. Quite straightforward. You need to just start with what you have and think where you need to go. So here we want to write y equals 2x minus 1/3 in general form. Now the first thing we know general form needs to have is no fractions in it. So I've got a fraction here, and the way to get rid of thirds is multiply everything by 3. Now there's three terms in this equation: the y, the 2x, and the negative 1/3. I have to multiply all of them by 3. So that will give me 3y, 3 lots of 2x is 6x, and 3 lots of 1/3 is 1. So I have minus 1 there. Now I have to get everything all on the same side. Now when you're working out which side to put it on, we need to make sure that the x's are positive. So we want 6x, not minus 6x. So I'm thinking we'll put everything all over on this side. That will leave nothing over here. So we'll have 6x's. We've taken away 3y from the left-hand side, so we need to take away 3y from the right-hand side as well. And we've still got our minus 1 sitting there. And then the general convention is to write all of that on the left-hand side, leaving the 0 on the right-hand side, which obviously some of you might have left that step out and automatically just written what was on the left on the right. So as you do more of them, you might find that you leave that step out and go straight to here. All right, going back the other way. Well, first thing we need to do is try and get the y's by themselves, because that's what gradient intercept form looks like. So I'm going to start by getting the y's on their own. The easiest way to do that, I think, is to probably just add 3y to both sides here. Clearly, I could add 3y to both sides, or I could subtract 4x and 5. I'm going to leave the 4x and 5 sitting there and add 3y to this side. Notice how everything's positive when I did that, whereas if I'd subtracted the 4x and the 5 over here, everything would be negative, which is okay. I just prefer dealing with the positive numbers, so I've picked that method. Now it's looking pretty close, except I want the y's on this side and all that stuff on the other side. So in the next step, I'm going to just swap everything onto the other side of the seesaw. And while I'm doing that, I need to have y on its own, not 3y. So clearly I need to divide everything by 3. So I'm going to do two things at once here. I'm going to take my 3y, I'm going to put it over this side, but I'm also going to divide it by 3. Now I'm going to take my 4x plus 5 and just move it over here. I haven't subtracted it, notice I've just done a full switch. The 3y's there, the 4x plus 5 is over there. But I don't have 4x plus 5. If I've divided by 3, I'm going to have 4/3 x. And I won't have 5, I'll have 5/3. Now see how the easiest way to take 5 and divide it by 3, rather than fiddling around with your calculator or working it out as a decimal, just divide by 3 and the answer is looking at you. And keeping your answer in fractions is totally fine. In fact, for the gradient, a fraction makes a lot more sense than a decimal, because it literally shows you the rise over run. And if you go to then graph that, you can clearly see the gradient and the y-intercept. Sometimes you might need to work a little bit harder to find the equation of your line. Now in this example, a line has an angle of inclination of 30 degrees and it passes through the point 0, 4. I've underlined the two clues. Find the equation of the line first in gradient intercept form and then in general form. Alright, let's have a look at gradient intercept form first. Now we've been given the angle of inclination. What that means is that the tangent of that angle, we've already learnt this, the tangent of an angle is equal to the gradient. Okay, so when we go to put it into that form, y equals mx plus b, which you can jot down like this so that you can sort of see, it's like a recipe, and you've got to find your ingredients to toss in the recipe. Now, tan of 30 is an exact one, it's one of the ones that we know. So m is going to be equal to 1 over root 3. Now, I need to find the y-intercept. Thankfully, I've been given that. The point 0, 4 is here. So it's got a y-intercept of 4 and the gradient of 1 over root 3. So it's going up sort of like this, not very steeply. So I can now just put that straight into this formula and say, therefore, y equals 1 over root 3 x, that's the gradient, multiplied by x, and then plus 4. And I'm done. Now for part 2, it makes sense to start with your gradient intercept form and then manipulate it to get it in general form. Now I need three things. I need all of the terms to be on the same side with 0 on the other side. I need a positive number of x's, And I also need to make sure there's no fractions in it. So it doesn't make too much difference which of those three things you do first. They all need doing. Let's start by getting rid of the fractions. So I'm going to multiply everything by root 3. So that will give me just 1x there, and 4 lots of root 3 here. Notice there's 3 parts to the equation, 3 terms, and I have to multiply all 3 terms. Now I need to get everything on the same side, and I also need to make sure I've got a positive number of x's. So I've got positive x's here, so I'm thinking this will be the side with all the terms. The other side can be the 0 for now. So I need to subtract root 3 lots of y from both sides, and then I've still got my 4 root 3. Now at this point you might have written both these terms down and put the minus root 3y at the end. That would be totally fine, because on the next step I'm going to put all of the bits and pieces on the left hand side and the 0 on the right hand side, and at that point you can tidy up and get them in the right order. So we're going to just have this like that equals 0, and that's our answer.